We move on to 6.4. It's our last section in this unit. We're going to be solving equations involving inverse trig functions. You've done the hard stuff. The 6.2, 6.3 stuff was the hard stuff. This is pretty simple comparatively. We're not finding the inverse function. We're just using the inverse to solve for x. In fact, let's just go ahead and make a note of that. We are not finding the inverse function. We are just using the inverse to solve for our argument x. Okay, our first question tells us to solve y equals 4 tangent 3x for x, where x is restricted to this interval. Now, don't worry about the interval. The interval they have given you, it works. They have restricted it to such a place that they can be sure that the solution you get will be a valid solution. So take note of the interval, but know that you are not being asked to evaluate that interval at all. We've got y equals 4 tangent 3x. The very first thing I'm going to do is solve for tangent 3x by dividing both sides by 4. What this gives me is y fourth equals tangent 3x. I'm going to take the inverse function to solve because if you remember back when we worked with inverse functions in college algebra, if you took the function, the inverse of the function, you got x, or the function of the inverse, you got x. Same thing here. That's what we're going to do. We're going to use the inverse function to solve. Since we're in tangent, we're going to take tangent inverse of both sides. We do the same thing to both sides of our equation. That's a valid action. So I take the tangent inverse of both sides, which means on the left I have tangent inverse of y fourth, and on the right, tangent inverse of tangent. That cancels each other out, like taking the square root of a square eliminates the square. I'm left with that argument 3x. I need to finish solving for x by dividing everything by 3, which means that x is equal to 1/3 tangent inverse of y fourth. And we're done. That's it. See, I told you were going to like this section. Okay, let's do the next one. Again, we're restricted to a specific interval, but we're not worried about that interval. We're trusting that they have given us something that is going to work and give us a valid solution. We've got the equation y equals 3 cosine 2x, and we need to solve for x. So I'm going to divide both sides by 3, which gives me y third equals cosine of 2x. And I'm going to use my inverse function to solve. My trig function in question here is cosine. So I take cosine inverse, or arc cosine, however you prefer to write it, of both sides. When I do that, I have cosine inverse of y third equals 2x, because this cancels out, if you will. Inverse functions undo each other. So to finish solving, I divide both sides by 2. My solution is 1/2 cosine inverse of y third. Okay, we just got a couple more pages. Let's do the next example. Example 2 says to solve an equation involving an inverse trig function, we have 3 arctan x equals pi. One thing that you need to be aware of is that this is not going to work in reverse consistently. Right now I'm starting with arctangent or tangent inverse means the same thing. Just be aware that this does not work in reverse consistently. And it's because of places where we have things that are undefined. For example, and it's not going to give you one that doesn't work, don't panic, but just because you guys need to be thinking class, because you're working toward your calculus sequence, many of you need to think about these things. For example, you cannot start with sine x equals pi half and then take sine inverse, because the sine inverse of pi half, this is outside my domain because this is greater than 1. Pi is about 3.14 divided by 2 is outside my domain of x. It can't work. One more time, don't stress about that. It's not going to give you something that doesn't work. Just be aware that we have only select problems that we do this with. So I'm starting with 3 arctangent x equals pi. I'm going to divide both sides by 3, which gives me arctangent or tangent inverse x equals pi third. And this is why I said this works, but you can't do the opposite, the reverse consistently because of taking the inverse that ends up outside your domain. This was going to work for us though. The reciprocal or the inverse operation of arctangent is just tangent. So I want the tangent of both sides. Tangent of the arctangent leaves me with x equals tangent at pi third. Well, pi third is a special angle on my unit circle. What is tangent at pi third? It's just square root 3. Okay, let's go again. We've got 2 arc sine x equals pi. When I divide both sides by 2 to get arc sine x equals pi half. At that point, I do that reciprocal or that inverse function, take sine of both sides, which gives me x is equal to sine at pi half. Sine at pi half is 1. All right, let's look at example 3. Example 3 is we're asked to solve secant inverse x is equal to cosecant inverse of 2. We're gonna pick a side to start with. Now remember that when I'm given information, I can just think of that as being an angle. I'm going to say, okay, I've got over here on the left secant inverse x. Let me go ahead and rewrite my problem. Secant inverse x equals cosecant inverse 2. I need to solve for x. So what I need to take care of is that secant inverse. So I'm going to take the secant of both sides. When I take the secant of both sides, this left side leaves me with x. And on the right, I'm interested in the secant of this angle whose cosecant function value is is 2, excuse me. Well, this is just some angle. I'm going to label this angle u, and I'm going to come over here and I'm going to say, okay, I have this angle u. Cosecant is reciprocal of sine, and the value I'm given is positive, so I know that my angle is going to be in quadrant 1 that we're interested in. This is my angle u. And the cosecant function value for u is 2. Well, cosecant is the reciprocal of sine, so it's r over y. And if r over y is equal to 2, then that's 2 over 1. So r is 2 and y is 1, and I need x. We use our Pythagorean theorem to solve for x. X squared plus 1 squared equals 2 squared. So x is the square root of 3. What I'm asked for here, x is secant of u. This is my angle u. Well, secant is 1 over cosine. So that would be r over x, where r is 2 and x is square root 3. When I rationalize, I get 2 square root 3 over 3. One last problem. Cosine inverse x equals sine inverse 1/2. I need to solve for x. I'm going to do that by taking the cosine of both sides. Cosine of cosine inverse leaves me with that argument x. On the right, I have cosine of some angle theta, where the information I have about theta is that sine inverse of theta is 1/2. So my sine function value at theta is 1/2. So let's go over here and say you've got positive sine again. So this is my angle theta. Sine is y over r. So I've got 1 and 2. Same situation as I had up there. If y is 1 and r is 2, then that means x is square root 3. This time, I want cosine of this angle. Well, cosine is square root 3 over 2. And we are done with 6-4.